Hey, what's up, guys? This is Juan from Repair Room, and I have here another MacBook that we're gonna try to repair right now. Okay, so this is not a big deal. Okay, this is a very simple, I guess, computer, but is one of the most popular computers from the 2013 to 2017. This is the MacBook Air 13 inches and use no USB-C. Okay. Oh, why it looks like this? Looks very weird. Okay, non-USB-C. Let me try to fix that. How you see the little square? Let's leave it like that for this video. Doesn't matter. Okay, so what's the problem with this computer? I haven't checked yet, actually. I had my customer saying that it doesn't power on. I think it is. There you go. So I'm connecting my charger and I don't have any green light. And I'm taking about 23 no 10 milliamps, so that's nothing. What it means is my computer, it's not communicating, it's not working how it's supposed to. The first thing I notice right now is I don't have green or amber or red or orange light. It doesn't matter how you want to call it. What that means? Oh, now understand what was the problem. What that means? That means that my sys1 wire isn't working. Okay. Oh, I don't have my schematics open. Let me open it very quick. Okay, so I'm gonna open it. We go to Apple, A1466. There's several, but there's like there's three different models. I'll go with the 00165. Okay, we have to remove the charger to the charger, the hard drive. So under the hard drive, you can see the model, but it doesn't matter. We're good. It's good like it is. Over here, you can see over here. Okay, so what is happening is I don't have sys1 wire. Sys1 wire goes around here. Sys1 wire. So how sys1 wire works? Let me show you. On this model, it doesn't show completely. So basically, we can test it here because it goes to the J9500. That is the flex. They communicate the LIO board or the LIO board, left input output board. Is this one where the charger connects. And so it's aligned. Is what's sys1 wire? Is a communication protocol of one cable. So basically, what is happening is the SMC and the charger through an IC, it's communicating after the IC, and the computer is verifying that everything is right and we should be good to receive the charge from the charger, so we won't create any bigger problem on the logic board. And who belongs to that process? Charging IC U7100, this model, SMC, charger. On this model, we have a OVP, over voltage protection. And unfortunately, there is not available on this schematic, but if we need it, I will show you with another schematic. But at this point, we're gonna try to repair the computer. We're gonna see how everything works. So the first thing I need to do actually, is show you guys my multimeter. There you go. Now you guys can see my multimeter. Now you guys can see my multimeter. We're going to start to test. So I don't have green light, I don't have red light. The first thing I'm gonna do is I'm gonna check my sys1 wire. It's right here. That's good. Oh, actually, I think I can test it here. I'm checking if my cable, this cable, is damaged, but it doesn't show that any damage. I'm gonna put it back. And I'm gonna check the sys1 wire in the connector, in the J9500. It's over here. Okay, so we're going to get the microscope. There you go. It looks perfect. Okay, I see it. How much this one wire it has to be is around 3.3 volts. So it's right here. And we have nothing. You see, I don't have this one wire. So I already know what my problem is. Now, the other thing is happening is we don't know if the charger is giving you charge. So what we need to check here, we go here to the charging connector. Oh, you guys are not seeing it. Okay, so I just tested here and it's no, there's not sys1 wire. You see, sys1 wire. Now the other thing is we're gonna check if the charger is giving me PPDC in G3 hot, is whatever is in my power supply, it's around 20 volts. And if not, we need to check PP5BS4 RS3. Okay, so let me show you this. This is PP3B42, no sys1 wire. Okay. So PP5BS4 S3, we for sure we don't have this. This is 5 volts on my state S4, on my state 4. That I think that's G1 or G2. I think it's G2. It's for sure it's G2 from CPU G2 state. But again, over here, the computer's not powering on. I don't have G3 hub yet. I don't know, but I don't have sys1 wire yet. So there's no reason for me to get to try to get a S4 at this point. So what I need to do, what I need to check if I have PPDC in G3 hot. I need my G3 hot. Which one are in this model? PP3B42 G3 hot and PPDC in G3 hot. After I get those two, I should have SUS suspension lines, suspension networks, suspension paths, I guess, and then we jump to G2, that is S5, S4, and S3, and then G1, S0, and computer should be working. At this point, we're gonna see how much is my PPDC in G3 hot. Again, we're gonna check on the J7000 over here, is where my connectors, when my charger connects. Okay, so let me show you the microscope. Here we go. There you go. And we got 20 volts. It means that my inrush limiter and my computer, my charger are communicating. We are good. Okay. So it's telling me here that once I get these powers in, this is my OVP. I'm not going to check everything. I'm just going to see if we have a, you guys are not seeing it again. Okay, here we go. So again, this is what we just test. We have 1995. It doesn't matter the max we can get here on this model. I think it's about 22. So what I was saying is, okay, so over here we got the 20 volts. There's an over voltage protection OVP over here. I'm not gonna check all this. I'm only gonna check if it's draining. If it's draining, if I have here same or almost same with whatever voltage we're losing over here, then I won't take care of, I won't even care about this. If for any reason I don't have voltage here, then yes, I'll check this area. Okay, so okay, we're over here. Over here, let's get the network. We can test it. There's a resistor in this area. Let me see it. There you go. Now let's go with the microscope. Boom. Now let's check. I'm in voltage. Yes, I should have 19 point something over here. There you go. So my OVP is working. My voltage drain. Now over here, my resistor is good. This is a diode OR, and we're good. And this is the entry to create. Sorry. And this is PP3B42 U3 hot. There you go. So basically, what I did is I just test all this. This is, I test here, then I test diode, then I test the big capacitor is one of these. I think it's this one, C7092, and then my output. So it's mean I have PP3B42 G3 hot. Still no understanding why I don't have my sys1 wire. However, there's another G3 hot that I need, and that G3 hot is PP bus G3 hot. Okay, let's search it very quick. This is the circuit. This is my charging IC. Okay, and this is how it creates. Oh, too bad, too much. This is how it creates PP bus G3 hot. Now I'm not gonna check this right now. I'm just gonna check my output. Do I have PP bus G3 hot? Okay, so I always check on my fuse. Well, what is my fuse? It's right here. This is my fuse, and we're going back to the microscope. There you go. And I'm gonna check my fuse. Let's see how much do I have on this side. I have 817 and I have 817. Okay, so very simple. I should have 8.6. That's how much I should have. But if for some reason, wait, is my camera dirty? Oh no. If for some reason, what the heck, it's 817, it means that my SMC is off. Okay. So this PP bus, it creates 817. Let's go back to the microscope, to the schematic. Here, this guy is creating 817 and 18, and then through these lines is being monitoring, the SMC is monitoring together with the U700. They talk together. If I follow this line, okay, very simple. It goes to this resistor, and then they call it SMC BMON I sense, and it goes to the SMC, you see? So they together use SMC and U7100, they monitoring AMON and BMON. If for some reason my SMC is off, it's not monitoring PP bus G3 hot, and it's not talking back to the U700, so U700 can change the frequency and up or push a little bit higher my voltage to 8.6. So what happens right now is my SMC is off. Now, how we're gonna check my SMC? My SMC it's very complicated, I see, but it have a very simple way to beat this. Okay, this is SMC powers. I got PP3B42 G3 hot. We already tested it, and we know that it's 3.4035, if I'm not wrong. We're going to recheck, of course. It goes to an inductor, a coil, and then they change the name for PP3B3S5 SNCBDTA. And that's the one it goes to D3 and is my voltage in for this IC. What else do I need? Of course, I need a clock. SNC clock 32K will give you this clock generator, and we'll talk about that if necessary we need it. And the other thing is we need, this is a very important line that almost all the time it gets damaged, SMC reset low. It means that it's gonna reset my SMC if my voltage is low. It means that my voltage is 0, my voltage is 0.2, is 0.3, 0.4, 0.5, is gonna keep it resetted or is gonna keep it off. You got it? Okay, good. So basically what it's telling you, I need voltage here. How much do I need? Let's see. Easily, already seen that R5100 and SNC reset L, it's together to a resistor. PP3B42 G3 hot is the voltage. So I already have an idea that SMC reset L have to be around 3.42 plus whatever, minus whatever is the resistance of the resistor. How big is it? And so we are going to have an idea. So we know it's 100K. Oh, that's a lot. But what that resistor is doing, that resistor is working like a pull-up resistor. We will talk about that in another video. So basically, this U5100, this guy is over here, is the one who has to create SMC reset low. What does this IC need? The 100K resistor R5100 in a good value, like with the value supposed to be, okay, with the right value. I need voltage in. Which one is my voltage in? Is PP3B42G3 hot one more time. And we know that this guy is good. Okay, I need PP3B42G3 hot one more time, but I believe it's not working. Another important thing on mobiles, laptop, this should be 3.42. It's telling me that on desktop, I'm guessing iMacs or Mac Pro have to be 5 volts. I haven't checked this. It doesn't matter. You have the time. It's telling you the schematics so you can read it. Okay, and what else do I need? It says that if this line is low, it's going to reset the U5100 with U5110. So what it means is it won't create my SMC reset low voltage. Same here, this is SMC on off. This is my power button. So we need these two on high, 3 point something. I know SMC on off L is 3.42 because same situation is coming for PP3B342. We can see it here, my network, net. No, that's a capacitor. Oh, back. Okay, so it's telling me that my SMC on off L have a 10K resistor that is coming from who? PP3B42G3 hot. So it's meaning if we have 3.43 here, we should have something very close to 3.43 here because they're always going to lose something very minimal through this resistor. So this is what a pull-up resistor. It's mean that this voltage is getting in from PP3B42G3 hot, but this is the line that goes to the keyword or to power button. So when you push power, you're putting these 3.3 volts or 3.43 or 42 volts to zero, and it won't affect this PP3B42 because we have a resistor in the middle. Okay, so this is gonna eat whatever voltage it can't drop anymore. Okay, so hopefully you guys are understanding. I'm just giving you a simple review, so if you don't have it, you can check it. Now, about this line, okay, this line, I believe it had to be something with keyboard, trackpad based on, yes, it's coming from keyboard. There you go, that's my keyboard. So what's happening is this line is coming from the keyboard. How? The keyboard is receiving PP3B42 one more time. PP342E3 hot, IPD. Okay, and then it's, I'm guessing some inside is go to some keyboard keys, and then it's coming back to this line. So if I do any combination on my key, if I push power, if I push something, because we know that we can reset the computers through key combination, this line will go down. Same principle there about the SMC on off line. Okay, so same principle. So it's going down, but how it's supposed to do is you need to get 3.3 or something very close to 3.42 volts on that line, that path. At least we're trying to reset the computer. So you have the computer not working, be careful of that line, like no power on. Sometimes we have computers that they don't power on, and we disconnect keyboard and they start. That could be the reason. I'm not saying it is all the time, but it could be. The other reason could be PP3B42 shorted through the keyboard, so you don't have one of the G3 hot, things like that. So you guys can have an idea. Okay. But basically, what we need is this guy letting this power going through. Okay, so that's what we're gonna check right now, and we're gonna check it where it's supposed to. Oh, okay, okay. I think we have a winner. I think we found the reason why we're having problems with this computer microscope. No, there you go. That's my U5110. That's the one. That's the IC what I'm been explaining. Okay. So let me search for the path. Okay. So the path I'm gonna check, I'm gonna touch right now is the path that has to give me the 3 point something. And we got nothing. Okay. You see? I'm sorry. I'm not good with my left hand, but let's see. Okay. We got nothing. No voltage at all. Now I'm going to check if my 100K resistor here in the back is good, but for that we need to take the board out. I haven't taken the board. Okay, so give me 1 second. Already removed all the screws just in case I have to do it. But the first thing I need to check if is that resistor is good. Okay, I think guys we found the problem. The reason why this thing is not working. There you go. That's why my SMC is off. But all the diagnostic with it is good. Now let's try to fix it. Hopefully that I see that SMC is good. So we're going to do right now, we're going to do a water damage process in it. Remember, before before you clean it, I always do a reflow. I'm going to do a reballing on the SMC no matter what. So let me remove all the silicone that tries to keep the SMC on place. So what I'm trying to do right now, I'm trying to remove all the sulfate. At the same, I'm trying to make the pads, the soldering active again. Already see there's like, you see there's a resist, that's a resistor. That doesn't work anymore, so we don't care. I'm gonna remove, let me put some more flux because I'm gonna remove that SMC. Ooh, look, this one too. This board, they're thick, so they dissipate a lot the heat. You see? But the SMC looks good. Hopefully it's working. I mean, it's good. Okay, let me put this like this. Perfect. Better. I like it. Okay. Now we're going to clean. Now it's clean time. Cleaning time. Okay. You see the disaster. Give me 1 second, guys. That's why you don't drink coffee on your table. The thing is, just did a mess. My wife bought me really a coffee cup with top. I don't know how to say it. With a lid, with lid, and but I used it once, and then I don't know where I left it, and it's been there like for a month, so I haven't can use it for now. I won't drink more coffee until I get that cup. Okay, so let's see what we got. The first thing I'm going to check if this is the R50 something, the 100K resistor looks very good. Actually, I thought it would be bad. Let me see. 100K is good. I'm sorry. Perfect. Now this one, I don't know how much is it, but it looks bad. So let me check it. Zero looks, it doesn't look bad. And this one is 100K, good. This one, I think this is an inductor, I believe. No, it's a 3.4, 3.5. I would say 3.3K. Now we're gonna check them. Okay, so this is 100K, good. I checked this one, 10K. No, actually, I'm missing this one. I'm missing this one. This is the one I show you guys that it was disconnected. So this one, it should be zero. Yeah, zero. And the other one is this. I think this is 100 again. 100K, yes. And this is a capacitor. Okay, it was giving me 3 point something. So if I go to diode mode on that capacitor, check it again. Let me see. It's not direct. Okay, so we're good. What are good about this? I only need so far one resistor, and the resistor is this one, and it is 10K. So I'm gonna get a donor board. Okay, you have a donor board here. Go back to microscope, and there you go. Let's take that resistor from there. Oh, before I do that, I had to prepare this one, so it will make my life easier. So the other thing I need to check, I'm going too fast. For example, look this. I have to fix this. That's the only one. It looks like yes. And then I have to prepare these two pads. This is not, it won't take any, it won't take the resistor. So let's prepare it. Okay. Okay, let me need to scratch a little bit. And where is it? Over here, right? Clean and see how everything looks. Okay. Oh, sorry. So let's make a small wire. Let's see if that cable goes to any other way, any other place from schematics. Okay. If you go to any other place besides, I think it's 1, 2, 3, 1, 2, this one. No, just from here to here. Okay, so I just need to connect them. And that's it. Where's my wire? There you go. Yes. Okay. Perfect. Okay. It's clean. Let's cover. We need to cover the cable, man. It looks ugly. Come on. Okay. So UV light. Almost done. Okay. Which cable, man? Looks perfect. Okay. Now let's put the resistor. Let me clean over here. Looks good. We put the new resistor. Okay, it's back to life. Well, not yet, but I mean that area looks way better than before, right? Okay, now what we're going to do? Should I test? No, I don't think so. Let's try to just do the reballing and put the flux. Then, I mean, the SMC. I was thinking to maybe check the pads. We're gonna spend the process like 10, 15 more minutes. I don't need, we need it. So I'll take my chance. Drink a little bit of water. Okay, now it's clean. Well, not clean, but my pads are flat. Okay. What do you think? Looks better? I think it does. Okay. So reballing on our SMC. Let's check that everything is okay. What I'm doing? Cleaning the SMC to be sure that all the pads are good. There you go. There you go. Okay. Who's ready for a reballing? Yes. An immense stencil. There you go. There you go. 183 Celsius paste, soldering paste. Let me prepare it. need what I need. Napkin to dry the pads a little bit. They come with too much oil. That's it. I think that's enough. Or no? Let's see. Ooh, it's dirty. Ooh, no. You see, that's why I have to remember every time I use it that I have to clean it. You can use a dirty stencil. Huh? You know, always trying to keep everything clean and organized. Okay, now we're good. There you go. Let's put the paste. One second. Okay. Back. That's perfect. There you go. SMC reballing is ready. A little bit more flux. Little bit flux here, not too much. You don't want to. Okay. Now you have to be sure you put it in the right position. On this one, it's very easy because the triangle. There you go. Don't want to go too hard because I have 70. I'm working this board 415 Fahrenheit. Oh, Celsius, I mean, I'm sorry. And 70 of air. But if with the 70 you go too hard, you move it too much, is gonna fly around, gonna fly out. So what we need to do is, you see that movement? It means it's already stuck at the board. So now you move it until it goes to the right position. There you go. You see how it's moving? Now you touch it. There you go. Now I'm gonna put more flux. Very careful without touching it. There you go. Now we're gonna make it dense. Now you can see it moving. Okay, we're done, guys. We are done. Give it a second. Let's go back to our table, to my table. There you go. Yes. Now the first thing is organize all this mess. In that way, we're gonna give it some time the board to cool down a little bit. Let's give it 30 more seconds, and then we're gonna test it and see how everything went. This. Now everything is organized again. And we're going to test it. The first test we're going to do is be sure if I have green light and if the fan is spinning. We have green light and we have the fan spinning. Oh, I touched it, but now let's see, we're gonna hear it chime. Or even before that, we're gonna try and see if my CPU, come on, really? There you go. Let's see if we have CPU activity. If we see this guy blinking, my CPU is on. We hear the chime. So that's it, my CPU is on. There you go, guys. Boom! We have our A1466 MacBook Air 13 inches 2017 back to life. I'm very happy with that. And the best thing about this is I did have enough time and I did it in the properly way. So I show you guys the process 100% explaining every detail, what I think is the most important thing on this repair. Now, how long should this repair with? It took us around an hour. How long it should take this repair? 20 minutes, 15 minutes. You connect it, you don't have, okay. Let me show you how I will do it if I'm not recording. Okay, so I connect the computer, no green light, nothing. Okay, so I go right there and then test. Where's my schematics? And test PP3B42 right away. So let's say that I connected, right? No light. Okay, let's go back to the table. Okay, even with a schematic, okay, I don't have, okay, the first thing I will go, P3B42, and I say, okay, I have, what is not showing it? There you go. So I'll go and I say, okay, PP3B42, and I have, what I'm touching? Oh, something is not connecting properly. Okay. So I connect and I have 3.43. Okay, we're good. Then I go right away and I take my fuse and I go 817. Then I go right away and I test my SMC reset low, and I got 3.3. I say, okay, and I'm not working. Oh, like I did, I tested. I don't have SMC reset low. Okay, is 0. Then I go to my schematics because I don't remember how to do that. Oh, where is it? And I go to my U5110 and I say, okay, let's check the resistor. This is the first thing I will check. Oh, it's in the other side. Then I will take the port out. Then I will see all the mess that we just saw. So that takes, and then to fix it, 15 to 20 minutes without not talking shit about, I'm going to do it in 5 minutes. No, 15 to 20 minutes is the time for this repair. Okay. Now, I took the time to explain step by step the thought process and how to approach it. Okay. Again, guys, it's been my pleasure to help you guys. It's been my pleasure to be here to take time of my daily repairs and show you a little bit. I hope you guys enjoy it and help you. Okay. Now, I need something from you. You guys, I need you to repost all the repairs. I need you guys to go my Instagram account and follow me. I need you guys to talk with other technicians about my YouTube channel that help me to get where I want to be. And I want to grow this very, very big. Okay. That's it, guys. This is Juan from Repair Room. See you next time.